If you are searching for somewhere still to let your mind come to rest tonight, you have found it. This is 60 minutes inside the ancient world of stone. No urgency, no noise, just the slow, quiet science of how the earth beneath you has always been moving. Whenever you are ready, we will begin. There are things beneath your feet right now that have been there longer than the ocean has existed. The ground you walked on today, the pavement, the soil, the stone, every layer of it carries a memory. Not a human memory, something older, something encoded in minerals and pressure and the slow passage of heat through a planet that has never truly been still. We tend to imagine the Earth as background, solid, given, the thing everything else simply rests upon. But that picture is not quite right. The ground is not a stage, it is a story. And it has been telling itself for 4.5 billion years. Every stone you have ever held was once something else. Every grain of sand was once part of a cliff. Every cliff was once part of an ocean floor. And that ocean floor was once magma rising from the deep interior of a planet still cooling from its own formation. Nothing in geology is finished. Nothing is simply there. Everything is between one thing and another. That is worth sitting with for a moment. The permanence we feel underfoot. The stability we count on with every step. It is real, but it is also temporary. Measured in millions of years rather than decades, but temporary all the same. Geologists have a phrase for this. They call it deep time. The sense that the history of the Earth is so long, so unimaginably extended, that the human mind can only approximate it. The way you might approximate the distance to a star by saying, far away. Deep time is not a metaphor. It is the actual scale at which the planet operates. And once you begin to feel it, once you really let it in, the world becomes a different kind of place. The pebble in a garden, the flat stone by a river, the exposed rock face on a highway cut, each one a traveller, each one carrying the record of somewhere it has already been, somewhere you will never go, a time you will never see, pressed into form and waiting to be read by anyone patient enough to look slowly. If the Earth were the size of an apple, its outer shell, the crust we live on, would be no thicker than that apple's skin. Think about that for a moment. The entire surface of our world, every mountain range, every ocean basin, every desert and forest and city, all of it exists within a layer so thin it is almost negligible when compared to the planet beneath it. The crust averages about 30 kilometers thick beneath the continents and barely 7 kilometers beneath the deep ocean. Below that begins the mantle, a vast region of rock so hot that given enough time it flows. Not like water, more like glass if you could wait millions of years to watch it move. The mantle makes up roughly 84% of Earth's total volume. It is the hidden engine of everything geological we can observe at the surface. Heat rising from deep inside the planet, from the core, from the decay of radioactive elements within the rock itself, drives enormous convection currents through this semi-solid material. And the crust above rides on those currents the way leaves ride a slow river. This is the foundation of plate tectonics. The outer shell of the planet is broken into roughly 15 major pieces, tectonic plates, and a scattering of smaller ones. They do not sit still. They drift, they collide, they pull apart. They slide beneath one another in a process so slow it is invisible within a human lifetime, yet so powerful it has completely remade the surface of the planet dozens of times over. Where two plates collide, rock crumples and mountains rise. The Himalayas were built this way, the Indian plate pressing northward into the Eurasian plate for 50 million years, folding the crust upward like cloth bunching against a wall. Those peaks are still rising now, a few millimeters per year, barely more than the length of a grain of rice. But given time, that is enough. Everything in geology is a matter of time. Where plates pull apart, the crust thins. Molten rock wells up from below, cools, and becomes new ocean floor. The Atlantic Ocean grows wider each year by roughly the same amount your fingernails grow, an inch or two. You cannot feel it. You cannot observe it in a lifetime. But the ocean floor itself records every millimeter, in magnetic stripes frozen into the cooling basalt like a ticker tape from the planet's past. And in some places, one plate dives beneath another and descends back into the mantle, melting, returning to the slow river of heat from which it once came. This recycling, this endless destruction and rebirth of the ocean floor means that none of the rock beneath the oceans is older than about 200 million years. In geological terms, that is recent, barely a chapter. The planet is not a museum. It is a process. Granite tells a particular part of that story. The stone that forms the cores of most continental mountain ranges, the rock that anchors the foundations of ancient landscapes. Granite began its life somewhere far below any surface we can reach. In magma chambers hidden within the crust, molten rock gathered and slowly cooled over millions of years. Slowly enough that crystals had time to grow. Quartz and feldspar and mica, each locking into place as the temperature dropped, forming the familiar pale grey speckled stone that we build with and carve and encounter on almost every continent. The size of those crystals tells you something about how long the cooling took. Larger crystals mean slower cooling, more time spent in the quiet dark beneath the surface. When you trace your fingers over the surface of granite, the rough grain of it, the flecks of mineral catching light, you are touching the record of that waiting. Millions of years of stillness in a hidden chamber, slowly becoming something new. There is something almost meditative about that. Carbon is one of the most ordinary elements in the universe. It forms the backbone of all living things. It drifts through the atmosphere. It settles on ocean floors. And under the right conditions, it becomes a diamond. Most diamonds form deep within the mantle, at depths of roughly 150 to 200 kilometers, where pressures are immense. More than 50,000 times the pressure at the surface, and temperatures exceed 1,000 degrees Celsius. Carbon atoms under those conditions arrange themselves into the most tightly bonded structure known in nature. Each atom connected to 4 others in a perfect lattice, rigid, transparent, extraordinarily hard. What brings diamonds to the surface is a process as dramatic as their formation is slow. Volcanic eruptions of a particular kind, deep, fast, and violently explosive, carry diamond-bearing rock upward through narrow channels called kimberlite pipes. These eruptions do not produce the kind of surface lava flows we associate with volcanoes. They punch through the crust rapidly, carrying material from deep within the mantle to the surface in hours or days. The diamonds arrive as passengers, carried upward from a darkness that has never seen sunlight. What is perhaps most striking is that carbon can also become diamond almost instantaneously under the right kind of shock pressure, the kind generated by a large meteorite impact. The energy released in those collisions compresses rocks so rapidly that ordinary graphite can be converted to diamond within moments, not over millions of years, within the duration of an explosion. Both paths, the slow patience of the mantle and the violent speed of impact, produce the same crystal structure, the same hardness, the same clarity. One arrives through geological eternity, the other through an instant of cosmic force. The same form, reached by entirely opposite journeys. Geology is full of those strange symmetries. Sedimentary rock holds a different kind of record. Where granite speaks of heat and depth, sedimentary layers speak of surface and time, of water and wind, and the patient accumulation of particles. Every year, rivers carry eroded material, sand, silt, clay, from mountains toward the sea. That material settles in layers on ocean floors and lake beds, each year adding a new deposit above the last. Over millions of years, those deposits compact under their own weight, the particles cementing together into stone. Limestone often forms this way, built largely from the shells and skeletons of marine organisms, corals, mollusks, tiny foraminifera, whose calcium carbonate remains accumulated on ancient sea floors. The Great Pyramid of Giza is built from limestone blocks that were once ocean floor. Within those blocks are the fossilized remains of creatures that lived and died in a shallow sea that no longer exists, in a climate very different from the desert where they now stand. Even the most monumental human constructions are built from what the earth recycled and offered up. Metamorphic rock sits between those two worlds. It begins as either igneous or sedimentary rock and is then subjected to intense heat and pressure, usually during mountain building, when plates collide and enormous thicknesses of rock are forced downward. The rock does not melt, but it changes. Minerals recrystallize, layers fold and warp. What was once flat and uniform becomes banded and twisted and dense. Marble is metamorphosed limestone. The soft calcium carbonate of shells and reefs, transformed by heat and pressure into something that gleams. Slate is metamorphosed mudstone, fine-grained, dark, split into smooth plains by the pressure it endured. There is a word geologists use for the degree of change that a rock has undergone: metamorphic grade. Low-grade metamorphism produces subtle changes. High-grade can take ordinary rock to the edge of melting, producing minerals that form nowhere else. Every rock is, in its way, a survivor. It has been subjected to something and come through as something new. The ocean floor is one of the least known surfaces on Earth. Most of it has never been directly observed by human eyes. Yet it is not simply flat and featureless. The sea floor is home to some of the most dramatic geology on the planet. Mid-ocean ridges stretching for thousands of kilometers where new crust is born. Deep trenches plunging to depths greater than the height of Everest. Underwater volcanoes called seamounts, rising silently in darkness. The Mariana Trench in the Western Pacific descends to nearly 11 kilometers below sea level. The pressure at that depth is more than 1,000 times the pressure at the surface. The temperature is just above freezing. Yet even there, life exists. Microorganisms, invertebrates, small fish, adapted to darkness so complete and cold so absolute that their existence still surprises scientists. The mid-ocean ridge system, the chain of underwater mountains where tectonic plates are pulling apart and new seafloor is forming, is the longest continuous mountain range on Earth. It stretches for roughly 70,000 kilometers across the planet's ocean floors. We have mapped it far less completely than the surface of the Moon. Most of Earth's geology is hidden. Most of it has always been hidden. That hiddenness extends backward in time as well. The very earliest crust of the planet, from the first billion years or so, has almost entirely vanished. Recycled through plate tectonics, eroded, metamorphosed, beyond recognition. We know something about that era from chemistry, from ancient zircon crystals that survive as grains within later rock, from isotopic ratios in ancient shields. But the direct record is thin, fragmentary. The Earth was alive in those early years, but it has not preserved much of what it did. What it has preserved is enough to be astonishing. In Western Australia, zircon crystals older than 4 billion years have been found embedded within younger sandstone. These tiny grains, no bigger than a grain of sand, are the oldest known material of terrestrial origin. They crystallized when the planet was barely a few 100 million years old. They are still here, still bearing witness, still holding their shape after 4 billion years. Glaciers write their own chapter in the geological record. At various points in Earth's history, vast ice sheets have advanced from the poles, covering enormous areas of the continents in ice sometimes kilometers thick. They move slowly, meters per year, but they carry extraordinary power. Rock embedded at the base of a glacier grinds against the bedrock beneath, carving valleys into U-shapes, smoothing rock surfaces into polished plains, depositing enormous boulders called erratics, hundreds of kilometers from their origin. The last great ice age peaked around 20,000 years ago. At that point, ice sheets covered much of North America, Europe, and parts of Asia. Sea levels were roughly 120 meters lower than today. Much of the world's water was locked in ice. Land, that is now ocean floor, was exposed, including the land bridge across which humans first traveled from Asia to the Americas. The geography of the world we inherited was partly a product of ice. As those ice sheets retreated over thousands of years, they left the landscape we mostly recognize today. The Great Lakes of North America were carved by glacial erosion and filled by meltwater. The fjords of Scandinavia and New Zealand were valleys deepened by glaciers and then flooded by rising seas. The flat, fertile plains of much of the Northern Hemisphere were built from glacial sediment spread by meltwater rivers across previously scoured rock. Even now, ice continues to shape the land in certain regions. Glaciers in the Himalayas, the Andes, and the Alps are still moving, still grinding, still carrying rock down slope. But they are also retreating, melting faster than snow can replenish them. The geological work they do is slowing, and the landscapes they have shaped are beginning a new kind of transformation under a warmer sky. What took thousands of years to build is now changing in decades. There is something humbling in that contrast. The patience of geological time, millions and billions of years of incremental change, and then the sudden acceleration of the present. Geology has always included sudden events alongside its slow rhythms. Earthquakes, volcanic eruptions, asteroid impacts, moments when the planet shifted quickly and violently. But the current pace of surface change sits in a different category, not geological, human. And yet the planet will continue. The geological processes beneath us operate on timescales that dwarf anything we can initiate or halt. The plates will keep moving, mountains will rise and erode, oceans will open and close. Whatever the surface looks like in 10,000 years or a million, the deep machinery will still be running, still shaping, still recycling. There is a particular quality to the silence of stone. Not the silence of emptiness, more the silence of something that has long since finished speaking in words and settled into a different kind of communication. Weight, density, the simple presence of having been here for a very long time. You learn something by standing in front of an exposed rock face, a cliff where the layers have been cut through by a road or a river, and actually looking at it. Not studying it, just looking. Each line is a year, or 1,000 years, or 100,000. The layers stack up without hurry, without awareness, simply because the conditions were such that material settled and accumulated, and eventually became something solid enough to be called rock. The accumulation did not know it was accumulating. It simply did what the conditions allowed. There is something familiar in that. The way a life builds without always intending to build. The way who you are now is a kind of sediment. Experience and time and quiet accumulation, pressed into something coherent by everything that came before. Geology is sometimes called the study of the Earth's memory, and that is not merely poetic. Rock does remember, not the way a mind remembers, with narrative, with emotion, with the ability to retrieve and reconsider. Rock remembers in the way that form remembers. The shape it took tells you what it went through. The minerals present tell you what was dissolved in the water. The angle of the layers tells you which way the currents ran. Everything that happened left a trace. Nothing was entirely lost. That idea that nothing is entirely lost, that everything that occurs leaves something behind in the structure of the world, is one of the stranger comforts geology offers. The planet does not erase, it transforms. What disappears from one form reappears in another. The shell becomes limestone. The limestone becomes marble. The marble eventually weathers back to mineral particles that feed a soil, that grows something that lives and breathes. Nothing is discarded, only rearranged. You carry minerals in your body that were forged in stars long before the solar system existed. Iron in your blood, calcium in your bones, elements assembled in the interior of suns that ended billions of years before Earth formed, carried through space in the debris of those explosions, gathered by gravity into the young planet, cycled through ocean and atmosphere and rock and living things, and eventually improbably, into you. The ground beneath you is not separate from you. It is earlier versions of what you are made of. Somewhere in the Pacific tonight, new ocean floor is forming. A ridge of mountains deep below the surface is pulling apart, and magma is rising through the gap, cooling instantly against seawater, building new rock. It has been happening continuously for tens of millions of years. It is happening right now. No one is watching. No instrument is recording it in this moment. It is simply occurring because the planet's heat has to go somewhere, and this is one of the ways it finds its way out. There is something restful in that image. The work that continues without anyone needing to direct it. The process so old and so established that it requires no attention to proceed. The planet does not need to be observed to function. Most of what the Earth does is invisible. The slow creep of plates, the crystallization of minerals in hidden chambers, the compression of sediment into rock in basins far beneath the sea. A vast amount of geological activity is occurring right now in places no one will ever see, in processes that will not produce anything observable for millions of years. The Earth is not performing for us. It existed for 4 billion years before anything capable of noticing existed, and it will continue for billions more. Our presence is a small parenthesis in a very long sentence. That could feel diminishing, but it doesn't have to. There is another way to hold it. You are the part of the Earth that can look back at itself. The planet, after 4.5 billion years of cycling matter through rock and ocean and atmosphere, produced something that could contemplate what it is made of. Something that could hold a piece of granite and understand, even approximately, what that stone went through to be here. You are how the Earth knows itself. That is not a small thing. Rocks at the surface are always becoming something else. Exposed to air and water and temperature change, they weather. Minerals that were stable under the pressure and heat of their formation become unstable at the surface. They break down. They dissolve. They are carried off by rain and rivers. Slowly, grain by grain, the most enduring seeming things give way. And in giving way, they feed the world. The minerals released by weathering enter the soil and the ocean. They become available to living things. Plants draw silicon and potassium and iron from the slow dissolution of rock beneath them. That mineral flow supports nearly all terrestrial life. The mountain does not simply erode, it feeds what comes after. Every ending in geology is a beginning somewhere else. The flood basalts that once covered enormous areas of the planet, released by supervolcanic events over millions of years, eventually weathered into the richest soils on Earth. Catastrophe, given time, became abundance. the soil beneath a forest, the sediment at the mouth of a river, the flat plain where something grows. Each one is rock, dissolved and distributed, a mountain made available. Even loss in geological time is generative. Let your weight settle now. Notice the surface beneath you, its solidity, the way it holds you without effort. It has been doing that your whole life and never once strained. That surface has a history you cannot feel, but that is real. The material beneath you was somewhere else before it was here. It travelled slowly across geological time to arrive in this place, this configuration, this moment of holding you while you rest. Everything beneath you has been waiting a very long time. Let your breathing slow. The weight of your body presses lightly on a surface that presses on soil, that presses on bedrock, that presses on the mantle below. You are connected right now to the deep interior of the planet, not metaphorically, physically. A column of material from where you lie, straight down, through the familiar and into the ancient, and eventually into the hot, unreachable core. You rest at the top of that column, held, supported, part of a structure that has no intention of giving way. Your breath moves slowly in the dark. Somewhere beneath you, over billions of years, something like iron cooled and solidified into the inner core of the planet. That iron generates the magnetic field that surrounds the Earth, deflecting the radiation of the sun, making the surface habitable. The very fact that you can exist here, that life can exist here at all, depends on that iron, on that cooling, on a planet that happened to be large enough and old enough to hold its heat long enough to do the work required. You are the result of everything going right. Not all of it, not always. There were extinctions. There were periods when life nearly ended entirely. There were moments, recorded in the rock, when the chemistry of the atmosphere changed so drastically that most of what existed could not survive. And yet something always did. Something always held on in some small place, in some particular niche. And from that remainder, given enough time, the world filled again. Resilience is written into the planet's history. The Earth is breathing tonight, not in the way you breathe, in a longer rhythm, continents exhaling slowly westward, oceans inhaling grain by grain as rivers deliver their sediment. A breath that takes millions of years to complete, but a rhythm. You are somewhere inside that rhythm now. Let your thoughts soften. There is no urgency in stone. No hurry in the slow accumulation of mineral upon mineral in the dark of an ocean floor. No impatience in the long cooling of granite. The earth has never rushed. Your mind can follow that. Each thought that arises, let it settle, the way sediment settles, without effort, simply because stillness allows it to find its level and come to rest. You have been moving all day, moving through a world that is also always moving. The plates beneath you, the slow tilt of the planet, the long arc of the seasons turning on the axis of an ancient rock in space. Everything moving. And yet this moment feels still. Stone teaches stillness not by being motionless, but by moving so slowly it seems motionless. You can do something like that now. Let your movement slow to almost nothing. Let the breath find its own pace, in and out. The way water moves through limestone, the way heat moves through the mantle, the way time moves through everything. You are made of the same atoms that have been cycling through this planet for billions of years. The carbon in you was once CO2 in an ancient atmosphere, was once part of a leaf, was once dissolved in an ocean, was once buried in sediment, and perhaps once released by a volcano and drifted for years through the sky before being drawn into something living. And here you are, one moment in a chain of moments so long it has no beginning you can point to. Here you are. The planet holds you now, ancient and unhurried. Its slow pulse beneath you, steady. Let that steadiness come into you. Let it move into your shoulders, your hands, your face. You do not need to hold anything tonight. The stone holds, the deep rock holds, the mantle holds. You only need to rest inside that holding. Deep below, somewhere in the darkness, a crystal is forming, mineral by mineral, patient, no awareness of time, only the slow arrival of something that was not there before. You are like that too, becoming something, in the dark, slowly, without needing to know what it is yet. The earth has been here for a very long time. It will be here long after. And right now, it is here with you. The same rock, the same slow heat, the same ancient cycling of matter through every form it can take. You are part of that cycling. You always have been, even in sleep, especially in sleep. Let everything grow quieter now. The breath, the mind, the small bright worries of the day. Let the ground hold you. Let the dark hold you. Let the long patience of stone be yours tonight. Sleep well.